Hello, I'm T4. We both know why you're here, so let's get into it. First, I'd like to welcome all the new subs and thank you for the amazing support. It means the world, and I am looking forward to this journey. Second, a quick reminder to check out OVD for a safe and fun place to game. Links, as always, will be found below. While you're down there, remember to leave a comment and help me get better at this thing. Or just ask me anything. In this video, I am going to show you a compacted version of my smelter, then explain how it works. But that means this is going to be a longer video, so feel free to jump around the timeline. But while your mouse is down there, remember to feed those algorithm gods. Hit some buttons to send them some food. Now, let's start with making some changes. Here you have the smelter I made when testing. Here's the one I made in the first video. And here's some room so we can get to work. If you're gonna copy my build, you're gonna need 2 sensors of your liking, 1 flip hook, 1 diode, 2 keypads, 2 magnets, 5 T's, 16 elbows, and 6 straight pieces. First, you need to pick the sensor you're going to use, then where you're gonna put it. Now put the A side of the argument on the output of the sensor. On the B side of the argument, attach a keypad. Out of the bottom of the argument, I have 2 T's. Off of the first T, I have an elbow pointed up into a straight, followed by a T into 2 elbows that flip around into a magnet. Off of the other side of the T, I have a straight with a 1-second delay into a second straight, then I use 3 elbows to connect the second magnet. Out of the bottom of the second T, I have 2 elbows to connect the smelter. From here on out, we're going to be talking the reset switch. First, pick what sensor you want to use, then pick where you want it. From the output, I have an elbow into a straight with a flip hook. I will be doing a video to explain how flip hooks work soon. The straight then goes into a T. Off of the left side of the T, I have an elbow into 2 straights. The last one having a diode pointed to indicate that the flow of the signal is moving away from the second sensor. This then connects me back to the first part of the system. Out of the other side of the T, I have an elbow leading into a T that is connected to the input section of the sensor. Off of this new T, I have a second T connected to a keypad. I put this here while testing in case I needed to do a master reset, but I'm happy to say that in the many hours of testing and filming, I never needed it. Meaning, you can use a straight piece here if you would like. Off of that piece, I have an elbow into a straight, followed by 3 elbows in order to connect the reset of the first sensor. Set the number you have selected for your system, and you're ready to go. Key things to know when you change this to fit your build: this diode must be in place or your system will break. As a reminder, the diode can go anywhere between these 2 T's, but must be pointed in this direction. Second, the flip hook does not need to be directly after the sensor, but it must be between the sensor and the first T. Okay, numbers. When I was testing, if any 4-digit number, 1,000 or higher, entered my system, I would have to do a full reset. Try keeping it under 1K, then do a stress test at the end. On the other end of the scale, if your number is too small, you will have trouble with the system triggering too fast and getting stuck in the on position. Try to keep your number around 500. I find that to be the sweet spot for while you're playing with logic, and then move your number around to find where you like it. You have your sensor, you have your argument, you have your number, you're ready to go. What machine can you hook up to this? Out of the output of the argument, you can hook up any machine you want this trigger to, well, trigger. You can add time delays, you can add lights, pipe valves. Just know that if you do anything that changes the number of the signal, it cannot re-enter the main line. I prevent this in my testing by using diodes at every T to mark the direction of flow. The last thing to say about the trigger is that wherever you decide to connect the reset signal, as it can go anywhere in the main line, be aware of the signal flow. You must have this diode in place. Yes, you can put it anywhere between this T and this T. However, I find keeping the diode close to the main line will save you down the road if you have to do problem solving. Now, into the reset trigger. As mentioned, you can trigger your system too fast. The smelter is around 2 seconds. If you want your sensor to be close to the smelter, just know you need to add a delay to the reset system between the sensor and the first T. You can put the flip hook and the time delay in any order, as long as they are in there before the T. The key to this system is having a sensor run into a flip hook before connecting to anything. Well, and the diode at the main line. As long as those are in place, you can connect anything you want to this system. Just know that if there is a risk of a signal entering the system that is not from the selected sensor, you will need a diode to stop it or risk breaking the whole system. Also, you cannot reset your sensor off of the main line. It must come off of the reset before it enters the main line. Otherwise, your sensor will be reset to 0 and will break the system. I encourage you to play around with the magnets and see what you can come up with. I have yet to get 100% lossless, but I'm pretty close. Other than that, please play around and show me what you come up with. Join my Discord and leave your builds in the Hydroneer channel. Links will be in the description. I hope this video answered some of the questions I've been getting about both my smelter and logic. Stay tuned for my next video where I attempt to solve the cut gem problem. And keep an eye out for videos that are going to be deep dives into each logic piece in hopes that people will be more willing to dive into logic. We'll see you soon.